Okay, 3.7 is the big one. We are going to combine almost every section. I can't really think of a section that doesn't have some contribution to this portion. And it's arguments and truth tables, which mean we're going to have kind of a string of statements. And this is kind of the classic what lawyers do of if this, and we saw the client do that, and they were over here doing this, then we must conclude blank. So that's the format we're going to do in this section. And so the definition of a valid argument is that when we get to the last row of our truth table, it's going to have truths all along the rows. Every entry will have a true value, which makes sense as far as validity goes, because it's going to be true no matter how you flip things around. If this statement is true and this statement is true and this statement is true and you get a true result, well, your argument is great. Where if it becomes down to, oh, wait a second, that first thing that you said isn't necessarily true, I don't know if we can really, then your argument starts to fall apart. And that's kind of an invalid argument. Is the fancy name for it is fallacy, which means that it's always going to be false, or you just straight up wrong. Because we can also have a fallacy when we're doing a truth table of an actual truth table, which would be all falses. But in this case, when we're dealing with arguments, it's one that just falls apart. We look at the last row, we see that there is at least one false statement, and we say, hold up, you're making this argument about how your client is not a murderer, but your argument falls apart in this row right here. There's a little bit of a flaw in your logic. And it seems like saying something has to have all truth statements in it is a bit of a stretch on having a valid argument, but we'll talk about why that is important, especially when we're going with an if-then statement shortly. But that's the idea. Someone would make all these arguments and make a conclusion, and we can say with these truth tables or with these kind of generated statements from truth tables, yep or nope. So this is something that lawyers can kind of do internally without having to draw down a truth table. I can't imagine it's built from the fact that they've done a lot of truth tables, all of their undergraduate law. I do imagine they did take a logic course, but it just comes with practice of you able to analyze these things and say, yes, that's definitely true, or maybe not. And so when we're testing the validity of an argument, it's going to fall down into this form of we have one premise, and we have another premise, and maybe we have another premise. We could have a lot of them. We could be a very long argument of 10 different premises. And then once we go through these statements, we say, great, those are my premises. Now I'm making my conclusion, and so I'm telling you the truth. My argument is valid. And we are going to do a truth table to say, wait, give me a second to make sure that's actually valid. Yes, you're getting truths all the way down the truth table, so good, or some error here that maybe you messed up with your second premise or your third premise. We don't typically have a lot of premises. Like n's usually a pretty big number in mathematics. We might have like 3. Typically, it's more of a 2 premise situation. And so here's kind of a cool example. I don't know if anyone cares about Star Trek, but there's a character in Star Trek that's supposed to be Mr. Logic that always makes logical statements and doesn't really let feelings get into the way of his decisions. And so in one of the episodes, he makes this claim. I believe they're trying to determine if the captain is dead. So his statement was, if Mr. Scott is still with us, then the power will come on. And then in the show, the power comes on. And so he concludes, therefore, Mr. Scott is still with us. So, well, let's see if he's actually being logical this time. So we're going to represent each of those statements in symbolic form. P is that Mr. Scott is still with us. Q is the power will come on. And so our first statement, or our first symbolic form, If Mr. Scott is still with us, then the power will come on. That is P implies Q. The power comes on, episode, or I guess he could say that as well. The power comes on, Q happens, it's true. Therefore, we are going to conclude that P, Mr. Scott is still with us. And this format that step 2 is shown under, that's a pretty popular format of how to test the validity of an argument. I think obviously the book does it a lot. I believe the worksheet and the test kind of fall into a form to recommend this. It's not required if you're really good at logic, but it's recommended because it's nice to kind of organize it. You're taking your form, you're saying this is my translated symbolic form, and you can kind of compare it. And then here's your next statement, and we're going to put a big line under it because the punchline, we want to see the conclusion of P. By the way, those 3 dots that are in a triangle, that is therefore. So it's therefore we can make this conclusion. So let's check it. So we're going to do our premise 1, P implies Q, or if P then Q. Premise 2, Q. Does that therefore conclusion? Does that imply there's a conclusion? So, well, let's make a truth table. True, false, false, true, false, false. My first premise of P implies Q. So that's true, false, true, true. My second statement is Q, which I already have that. And so now I'm going to kind of set up my step before my big conclusion, which is my premise 1 and my premise 2. Again, it seems kind of weird because my premise 2 is just Q, but that's fine. So P implies Q and Q. So looking at my truth table, that's true, 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 false, 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 true, 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 false, true, false, because we have an and statement. So both things have to be true in order for it to be true. And now our last column when we're doing arguments is always going to be our overall statement. I have my premises, they're grouped in ands. I have my conclusion. I have my if, then my conclusion. So, well, I look at my column right before it. I get true, false, true, false. I'm trying to see if that thing then P, well, I look back at my P column, which is true, true, false, false. So it's kind of weird to think about it backwards, but going from my third column, I see a true, and then my P is true, so it's a true result. My third column has a false, my P is true, so that's a true result because of the weird rules of if-then statements. My third row has a true in my second to last column and F for P. And my last one has my last row has a false in my second to last column, all of my premises, and a false for my P. And so that's going to return a true statement. And so this is what I was talking about, that we can say, it seems like a true argument because I have 3 true situations and 1 false. But when we're making these arguments, we don't want to have any holes in our argument. So if we are returning 1 false value, then there is a scenario that could happen that would make this argument false. I'm making this claim, I'm going to make this conclusion, which is true no matter what, so I am right. Well, in this particular case, we could have Mr. Scott is not with us, and the power could come on, and all of your statements could hold true, but your conclusion is not true in that case. That's wrong. He's gone, even though your argument is built in such a manner that if he's not here and the power comes, or if he is here, the power comes on, you were right. If he wasn't here and the power doesn't come on, then you were right. If he was here or if he wasn't here, wait, I don't remember which one I was on. If he wasn't here, then the power comes on, you're right. If he was here and the power doesn't come on, you're right. But we want to always be right. And so this is what I was kind of talking about, where it seems like there's not a lot of margins for error, but it is an if-then statement as well. And so since it's an if-then statement, there are going to be situations where maybe your premises overall are going to be false, but if it's false, then my if-then statement's going to always return a value of true. So really, that's the format of arguments, is that you go through and make your arguments, and people say, okay, I see what you're saying. I see what you're saying. Let's say that's right. Let's say that's right. Let's say that's right. That doesn't necessarily imply what you are getting at. And here is where you're wrong. Here's a case where that would fall apart. Let's see it again. Determine whether the following argument is valid or invalid. I can't have anything more to do with operation. If I did, I'd have to lie to the ambassador, and I can't do that. So here's our argument. Is it valid? Well, let's write it out. Kind of the format with our two statements are: if I have anything more to do with the operation, I'd have to lie to the ambassador. That's my first statement. I can't lie to the ambassador. That's my second statement. Therefore, my conclusion is I can't have anything more to do with the operation. So let's say P is I have more to do with the operation. Let's say Q, I have to lie to the ambassador. So if I'm going to write this out in symbolic form, my first statement will be if P then Q, I had anything to do with the operation, comma, implied then, I have to lie to the ambassador. I can't lie to the ambassador, tilde Q. Therefore, I can't have anything more to do with the operation, tilde P. P is I can't have anything more to do with the operation, tilde P is I can't have any more. And again, we're going to build the argument. Like if we have this argument here and he is not telling the truth about how he can't lie about the ambassador, we probably shouldn't be making that argument, or we're almost assuming these premises are going to be true. But that's an aside. Let's just build the truth table and not get lost in, I don't even know what we would get lost in at this point. So our first premise is P, if P then Q. Our second premise is tilde Q. So if we're going to build the truth table, and again, we would probably generate this column by column if we were actually doing the problem. But our truth table is on the left side now. I kind of covered up the previous statements. I built my P and my Q. I need my first premise, if P then Q, so true, false, true, true. I need my second premise, tilde Q. Well, I just flip my column of, or flip the truth values of my column Q. Now I'm going to kind of combine all of my premises, if P then Q and tilde Q. Well, let's look at it. We have false, 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 true. And tilde P, flipped P, false, false, true, true. We have our last column. So we're going to look at our third to last column, and we're going to compare it with our second to last column, because our second to last column is our conclusion. And let's see, false, false for an if-then statement is true. False, false for an if-then statement is true. False, true for an if-then statement is true. And true, true is for an if-then statement is true. So really we want to, the only case that we're going to have issues with is if we have a true overall thing in our premises and we return a false value for our conclusion. And so this is correct with the argument that was being made in, I believe, either an article or a book. I think it's an article. That they told the truth. In any scenario that they are going through, they are telling the truth. If P is true, if Q is true, if they're both false, if one's true and one's false, then this overall statement's false. And so we would say this argument's valid. He agreed. What he's doing is he's telling the truth. And so this is kind of, I mean, I've never sat into my course captain's course, and maybe he has a lot of success with going through this statement or this process. And what he does is he kind of says, okay, I mean, it's hard to give a percentage because you can't really give a percentage of arguments, and there's a billion, a million, or infinite amount of them. All that aside, a lot of arguments, let's give a percentage, 95% of arguments fall into this form. There's a very formulaic way that humans argue. And so if we can take a statement or a group of statements, if we can put it in symbolic form and it falls into these categories, we can automatically say, oh, thank goodness, I don't have to do a truth table. Boom, it's going to be valid. Boom, it's invalid. But as I said, it's not always going to fall in the case. And I know truth tables are a headache, but A, I'm bad at just memorizing entire tables of formulas and stuff like that. And B, this doesn't cover every single case. It covers a lot of cases, a lot of arguments, but it doesn't cover all of them. So I just want you guys to be capable of, if it doesn't fall into one of these common argument forms, then you would still be able to determine whether or not an argument is valid or not. And so just to kind of go through these, my first row is all of these are valid situations. If someone's making an argument of if P then Q and P, therefore Q, we're good to go. If P then Q, tilde Q, therefore tilde P, good, contrapositive reasoning. Also, this is kind of, if you are into mathematics, that's pretty similar to proof by contradiction. You would say, oh, now let's assume that the Q is false. Let's assume that what we said is false. If we can reason that the initial statement is also false, then great, we have a valid argument. Another one is P or Q. Tilde P implies Q, which makes sense. If someone's saying, I'm either eating dinner or going out to the movies, and you say you find out that your friend is not eating dinner, then someone could argue that they are at the movies, and vice versa. If you find out that, if you say that I'm going to the movies or I'm eating dinner, and I find out that I'm not going to go to the movies, then I can conclude that I'm going to be having dinner. And so that's the thing. Like I said, these are pretty common statements that people make. If P then Q. If it's raining, or if it's raining outside, I will grab an umbrella. Well, I didn't grab an umbrella, so it must mean that it's not raining outside, assuming I didn't make a huge mistake or something like that. And then finally, the transitive reasoning. If P then Q, and if Q then R, we can imply that if P then R. We can also imply that if R is false, if tilde P, then if tilde R, then tilde P. And that might seem kind of familiar to some people, because that's essentially the transitive property. We've got to be a little bit careful, because the transitive property is that if A is equal to B and B is equal to C, then A is equal to C. Where we don't have equivalence here, but that's where we can see that relationship of relating P and Q, relating Q and R. So there's probably going to be some relationship between Q and R. Now, a lot of invalid arguments that we make, we call them fallacies of, ooh, that's a pretty common argument, but it's not quite right. You can't make that conclusion. And so honestly, the most common one is that fallacy of the converse of, we kind of think of an if-then statement as an and statement. And so we try to kind of force reasoning that doesn't really check out. If it's raining outside, then I'm going to grab an umbrella. If I grab an umbrella, that has to imply that it is raining outside. That's not really true. Maybe I just grabbed an umbrella to be safe and didn't want to chance it that it might be raining on me. So that's a very common incorrect argument that seems like it's true. Similarly, the if P then Q, and tilde P, so if I find out that I don't have the if statement true, well, I can't conclude that tilde Q. And so I want to avoid saying that like these are arguments, they are arguments, but the implication, the conclusion isn't guaranteed to work. So don't think of these as arguments that will work. They won't. They're common arguments that people make with incorrect conclusions. So just keep that in mind. I don't want to kind of mince things around. Similarly with or statements, if we assume one thing is true, we generally assume the other thing is false, which I think a lot of people agree with as far as straight English goes, but that is not true as far as straight logic goes. This is something we've been talking about since doing set theory. It's not necessarily guaranteed. And then finally, with the misuse of the transitive reasoning, this is what I was getting at, that we can't kind of go backwards. So if I say if P then Q and if Q then R, then I can conclude that R, or if R then P, I can kind of go backwards, which I can't. I can only go in that forward direction. Also, I can't negate my P and imply that that will be a negation of R. So it's a lot, I'm aware. Another great thing to have on your note card if you want to use these. Like I said, if you can find something and you can throw it somewhere in this table, you're going to save a lot of time as far as truth tables go. You could form your argument. You could say, that's a contrapositive reasoning. Boom, I have a valid argument. I don't have to do my truth table. Or, oh, that seems like it's true, but actually that's a fallacy of the inverse. So I can conclude in that case that it's not true. It's not a valid argument. So it's cool if you can get things to fall into one of these categories, but that's not always the case. And like I said, I'm not good at memorizing all of these things. And so I think I know the first two in each row. I could probably reason the other ones, but I certainly don't have them memorized. Like if you walked up to me on the street and said, give me the misuse of disjunctive reasoning, I would be very weirded out that you shouted that at me, but I also would not be able to answer that question. So let's see this in practice. Here we have a couple of arguments, which you might see and think, oh, okay, there's 3 different questions. And I'm going to have to make a truth table for all of them, and I'm going to have to translate all of them. So I guess I'm just going to have to cancel my plans for the weekend, where these are arguments that show up so often that they will fall into this table, and we can kind of make a quick conclusion. We still have to translate it though. So there is no need for surgery. I know this because if there is a tumor, then there is need for surgery, but there is no tumor. There's my argument. It's kind of hidden, but I have my conclusion. I have my, what's the name of them, premises. And so I can build my argument and see if it falls into this table. So let's say P is there's a tumor, Q is there's a need for surgery. You can kind of fill out this, I don't know, equation seems like a misuse of the word, but I guess maybe format or almost a table to translate it. So if there is surgery, then if there is a tumor, then there is need for surgery, P arrow Q. There is no tumor, tilde P. Therefore, there is no need for surgery, ... tilde Q. So I could make a truth table. Honestly, if I were you, I would make a truth table to figure out whether this was valid or invalid, because I don't have this table memorized. But if I did have this table in front of me, I would look and say, oh, maybe I don't have to do a truth table. Okay, let's look through the valid arguments and my invalid arguments. And oh, that's a fallacy. That is not a valid argument, and I would say this is invalid. Didn't have to do a truth table. Solved it pretty quickly. I mean, translating always is a little bit of a headache, but certainly faster than making a truth table. Here, we're doing second statement. The emergency of democracy is a cause or hope, or environmental problems will for hope, is a cause for hope, or environmental problems will overshadow any premises of a bright future. Environmental problems will overshadow any promise of a bright future. Therefore, the emergence of democracy is not a cause for hope. So P is the emergence of democracy is a cause for hope. Q is environmental problems will overshadow any promise of a bright future. So very long-windedly, my first sentence is an or statement, P or Q. My second statement, or my second premise, is just Q, just repeating Q. And my conclusion is that, well, democracy isn't going to be enough for us. It's a tilde P. And so again, I could go about making a truth table. Truth be told, it doesn't take very long, but let's see if it falls into any of our nice categories. P or Q, Q, tilde P, Oh, I don't think I circled the right thing. I think that's also a misuse of a disjunctive reasoning, right? Because we have P or Q, we have that Q is false, therefore we're implying P is true. So my circle is not in the right spot. This is also an invalid argument. Circle should be in the one below it. Just get rid of it. The circle should be in the one below it. You can actually draw it, why not? It's this one, specifically the left one. And so, or no, the right one. And so this is also an invalid argument. Maybe democracy will give us hope. I don't know. So if you wanted to use this route, I'm going to do one more example. But if you wanted to use this route, then you would still have to kind of form this equation, form this table. It's not a truth table, but form this table, and then just write, that's a misuse of disjunctive reasoning. It's an invalid argument. That's fine. Again, I don't love it, but you know, just because I don't love something doesn't mean it's not a good thing to, good way to solve a question. Seems like we can't see the bottom of this. There we go. Okay, last argument. If the evidence of the defendant's DNA is found at the crime scene, we can connect him with the crime. If we can connect him to the crime, we will have him stand trial. Therefore, if the defendant's DNA is found at the crime scene, we can have him stand trial. Cool. This seems pretty cool. It's seems very realistic. We have the crime scene, DNA, trials, stuff like that. We also have 4 statements here. P is the evidence, or not 4, 3. P is the evidence of the defendant's DNA is found at the crime scene. Q, we can connect him with the crime. R, we can have him stand trial. Cool. So truth tables with 3 statements are a headache. So if I had this table anywhere near me, I might even start looking for the table. I would probably avoid using a truth table. Honestly, don't know if that's true. I really like truth tables, but I could see why people would want to avoid truth tables. It's hard to keep track of the things. So let's translate these 3 statements into arguments and see if we can make it that we have something in our table. We can find something in our table that falls into this category. So if evidence of the defendant's DNA is found at the crime scene, we can connect him with the crime. That's an if P then Q statement. If we can connect him with the crime, then we can have him stand trial. That's a Q implies R statement. Therefore, we can conclude that if the defendant's DNA is found at the crime scene, then we can have him stand trial. So therefore is a pretty common conclusion statement in mathematics, also in logic. And again, that's the 3 dots. So now to hopefully avoid making a truth table of 3 if then statements and an and statement, then an overall if then statement, we look at our table. We have P, if P then Q, we have if Q then R, we have if P then R. Am I missing the big reveal? There we go, cool. So by transitive reasoning, that's a valid argument. And I did match that up right, cool. So we avoided making a giant truth table with 3 different statements flying around and 2 different premises flying around and an overall statement, and we just can conclude, boom, this is a valid argument. Great. And so finally, if we're able to identify an argument or at least a couple of premises and relate it back to that table, then we can kind of make some of our own conclusions. You know, some people are like, don't leap to the wrong conclusions. Well, you can leap to the right conclusions if you have this table, and you can make it so that your statements fall into one of these categories. So here we have, if all students get requirements out of the way early, then no students take required courses in their last semester. Some students take required courses in their last semester. So what conclusion can I make? Well, let's again go into translating everything. So P is all the students get the requirements out of the way. Q is no statements take required courses in their semester. You could maybe argue that Q could be phrased a little bit differently, or that could be a tilde Q, as long as you're keeping things straight and know what category you're falling into. well, not know what category you're falling into, know whether or not your statement is valid or invalid. That's kind of the weird thing about negations, is that someone could say, oh, I didn't want to write no students, I wanted to write the negation of that, and that's fine. Okay, that's an aside. So here we have if all the students' requirements get out of the way early, then no students take required courses their last semester. That's an if P then Q statement. We also know that some students take required courses in their last semester. So that's tilde Q. Again, this is kind of cycling back to maybe the first section, that the negation of no is some. It's not all, because that's a little bit generous, but some. So that's where we get the tilde Q. Well, let's see if this is any of our valid arguments. I want to pick a valid argument. So then I could have, well, a valid conclusion. I don't really want an invalid argument, because that doesn't necessarily mean that the conclusion is false. It means that I'm not sure that the conclusion is true, which sounds like the same thing, but it's not. It is slightly different. So we're not looking for invalid arguments, because that won't tell us if a conclusion is wrong. But if we have a valid argument, then we can say, okay, well, I'm going to say this is my result, and I'm going to be right. So looking at my table, I have an if P then Q statement. I know that my second statement, or my second premise, is tilde Q. So therefore, well, I get the result of tilde P, which now I can write out that P is all students get requirements out of the way. So the negation of all students is that, well, kind of a straightforward one is that not all students get requirements out of the way early, which is true. Kind of a clunky way to say it. Instead, how I would say it is that if I know that not all students get requirements out of the way early, I mean, some of them do. Maybe all of them, but certainly some of them do. I can say with confidence that some of them do not get requirements out of the way early. So that's another kind of cool thing about this standard form of arguments table, is it allows you to reach conclusions, which is pretty difficult to do when you have to go through this whole truth table thing, because you can't really, I guess you could come up with one and then test to see if that gets you all truths, but it's harder to see that, make a good guess, versus here, if you can make it fall into one category of direct reasoning, contrapositive reasoning, anything in the first row, then you can make a valid conclusion, which is kind of cool. That's it.